In this lesson, we'll be looking at drawing exponential graphs. So let's look at what are the kind of graphs we have already done. So we have already looked at linear graphs, so where the equation of the line is given as y equals mx plus c, and then in that case you get the graph as a straight line. Then we also have looked at quadratic equations and quadratic pattern. In that case, if you draw the graph of expression or equation given as y equals ax squared plus bx plus c, you will get the graph as a parabola. Now the basic exponential graph or the basic exponential equation can be written as y equals p to the power of x. This is our basic exponential graph, and let's see how the graph of this exponential function looks like. So I'm going to take the example of y equals 2 to the power of x. Now the best way to draw the graph and see how the graph looks like is to make use of the table of values. So I'm going to choose some values of x here, and I'll be going for 3, 2, 1, 0, -1, -2. And since my equation is y equals 2 to the power of x, you have to replace x by 3, then you'll be replacing x by 2, then 1, and so on. So let's find the y value. So your first value will be 2 to the power of 3, which is 8. So your first set of coordinates will be 3 and 8. Then the second value will be 2 to the power of 2, which is 4. So your second coordinate will be 2 and 4. Then 2 to the power of 1, which is 2. So your next coordinates will be 2, 1, and 2. 2 to the power of 0, which is 1. Remember, any number or any variable to the power of 0 is always 1. We have already discussed that while studying rule of indices. So your set of values will be 0 and 1. 2 to the power of -1, which is half. So I'm going to write it as 0.5, which is -1 and 0.5. 2 to the power of -2, which is 0.25 or 1/4. So your set of values will be -2 and 0.25. Now before plotting the graph, let's look at what is happening with this pattern. So the value of y is giving you an exponential pattern. How will you know it's an exponential pattern? So if you look, if you divide 8 by 4, the answer that you're going to get will be 2. So basically, if you divide the two consecutive terms, you will notice that each time you're going to get the answer as 2. So this is what is special about exponential graph. The ratio will always be the same, and that is again a hint for you to find out whether it's an exponential pattern or whether it's a quadratic pattern or linear. So for linear, if you're given a pattern like this, so each time if you are going up by the same value or you're going down by the same value, then it becomes a linear pattern. So this is called first difference, and I'm not going to go into detail, but so this is how you find out your linear pattern. And in exponential, when the ratio is same, then it becomes your exponential pattern. So which means if I am going backwards, each time if you times by 2, you will get the previous number. And you will also notice that equal ratio is your p-value. So that's something that we can keep in mind for now. All right, let's plot the graph and see how it looks like. So the first value that we have is 3 across and 8 up. So 3 across and 8 up, this is where my value is going to be. Then 2 and 4, 1 and 2, 0 and 1, -1 and 0.5, then -2 and 0.25. And you will notice that as you will go down or as you will go below your -2, so as the values of x become smaller and smaller, your graph or the curve will become closer and closer to x-axis, but it will never be 0. So this is something special about the exponential graph. And this curve or this line which is getting closer and closer to x-axis, which is this one, has got a special name. In this case, I can say my asymptote is at y equals 0, and my intercept is, my y-intercept is 1. So that's something that I've got from this graph. Now this is the basic exponential graph for y equals 2 to the power of x. Let's look at one more graph and let's see how the graph of that function looks like. If I give you the second example, so let's draw the graph of y equals 3 to the power of x. Again, we are going to draw a table of values. Let's choose some values here. X, y, and xy. So your table of values, you can choose the values for x as 3, 2, 1, 0, -1, -2. So your y value will be 3 to the, y equals 3 to the power of x. So your first value will be 27, then 3 to the power of 2, which is 9, 3 to the power of 1 is 3, 3 to the power of 0 is 1, 3 to the power of -1 is 1 over 3, 3 to the power of -2 is 1 over 9, and so on. So your set of values will be 3 and 27, 2 and 9, 1 and 3, 0 and 1, -1 and 1 over 3, -2 and 1 over 9, and so on. Now again, let's look at the pattern here. So now you will notice 27 divided by 9 is 3, 9 divided by 3 is 3, 3 divided by 1 is 3. So basically here, if you want to go upwards, each time you're timesing by 3, and you notice that your p is 3. So that's your ratio. All right, let's draw the graph. So if I have to draw the graph of this function here, so my first value is 3 across and 27 up. So I don't have 27, so I'll leave that value. I'll go on with 2 and 9. So 2 across, 9 up, and 1 across, 3 up, then 0 and 1. And we have got the same y-intercept here, which is 0, 1. So that is something same in the graph for y equals 2 to the power of x and 3 to the power of x as well. And then the next value is -1 and 1 over 3, which is going to lie somewhere here, and it will get closer and closer, closer and closer to x-axis, but it will never be touching your x-axis. That is why the asymptote is still at y equals 0. In this case, you will notice that it is just going to be somewhere here. So this is my asymptote, and now this is the graph for y equals 3 to the power of x. Now you will notice that the graph for y equals 3 to the power of x is steeper than y equals 2 to the power of x. So that's another feature that we can see in this graph. Now you can try a drawing graph for y equals 5 to the power of x and see what happens to your graph, and you will notice that the y-intercept will still be the same. And we are going to look at, when we are going to look at our translation with respect to exponential graphs, then it will make more sense to us, and then we can use the information that we have just got to translate exponential graphs, which I'm going to do in the next lesson.